Hello everyone. This presentation is talking about an overview of axial flux magnetic gear and magnetically geared permanent magnet machine topologies which have been created so far. So I will start my presentation with the brief history of magnetic gear topologies with the high performance magnetic gear topologies as well. Principle of operation of magnetic gear and magnetically geared machine will be clarified. Uh, the topologies which has been created so far of axial flux magnetic gear and magnetically geared machine will be summarized. I will mention to the application for this kind of machine, and I will finish my presentation with some conclusions. For the mechanical gear, this kind of gear consists of two discs, and both of them connect to each other by a slot and tooth. So the torque will be transferred from one disc to the other by this connection. So for this one of gears, high torque density can be achieved, but application and cooling are always required in addition to the noise and vibration. And for early time, magnetic gear has been presented by changing the slot and teeth of conventional mechanical gear by north and south permanent magnets. So the torque in that case will be transferred by the attraction force between uh, uh, both discs permanent magnets. So overload rotation can be achieved since there is no physical contact between both discs, but the utilization of magnets is poor for this kind of machine since only the alignment magnets are responsible for transferring torque. Another thing is the torque for transferred from this kind of machine is low due to the material of permanent magnet in that time. Actually, each mechanical gear has its magnetic gear counterpart, as we can see here in this figure. So in 2002, high performance magnetic gear has been presented in radial shape. So this kind has one inner rotor and outer rotor and a modulator in the middle, which consists of iron pieces. So this machine has a high performance torque actually, and there is another topologies has been presented as well, like axial topologies, which with two discs and the modulator in the middle, and linear or tubular topology as well with three cylinders, both of them a surface mounted permanent magnet and modulator located in the middle of in between both permanent magnet mover. So in this presentation I will only present the axial flux topologies. So I will start with the principle of operation of this kind of machine. So if we assume that the very simple construction of permanent magnet rotors, which the first one has a PL pole pairs, the second one has PH pole pairs, and a modulator located in between both rotor with NS pole pieces. So the relationship between these three parts can be achieved by this formula, which is the number of pole pieces equal to the summation of both rotors pole pairs if we need a high torque achievement. So when the torque is applied to one rotor by a prime mover, so this rotor will be rotating at specific speed. So the flux created by this rotor will be rotating in the air gap. This flux will be modulated by the modulator. So in that case, the rotating flux on the other side of the modulator will create a torque in the other rotor, and the other rotor will be rotating at a specific speed. So if we assume that the modulator in the middle is fixed, so the relationship between uh, both rotor pole pairs is called the gear ratio. So in that case, the output torque will be the gear ratio times the torque input by the prime mover. So if we assume that the first rotor has 7 pole pairs, the second one have 5, and by this formula, the number of pieces in the middle equal 12. So the gear ratio, it will be 1.4, and that means that the output torque will be 1.4 times the input torque produced by the prime mover. On the other side, if the modulator here have a winding, so in that case, the same mode of operation can be achieved here. So for this simulation mode, the torque produced and the output rotor will be created by the gearing effect, and the same time is by presenting the winding in the modulator. So in that case, induced EMF will be presented here in this winding. So in the same times as this machine will work as a magnetic gear and generator in the same times. And on the other side, if this winding is injected by current, so in that case, this machine will be operated as a motor. So the electromagnetic torque of this machine can be calculated by the traditional formula of the torque. So the output torque will be the summation between the gearing effect torque and the electromagnetic torque produced by the current injected in the winding. So for this kind of machine, a combination between magnetic gear and permanent magnet machine can be achieved. And the same times, due to this combination, the overall size of machines, when we connect magnetic gear axially with permanent magnet machine, will be reduced by this combination of magnetically geared machine. So I will start with your presentation of the topologies which has been created so far. I will start with the first topology, which presented by Mazzini in 2006. This topology has a two rotor with surface mounted permanent magnet and the modulator in the middle. This machine used a rare earth permanent magnet and torque density of 70 kilonewton meter by meter cube is achieved. Another one is presented by Ashery in 2013, but the modulator is approximately the same, but both rotor used a flux focusing permanent magnet rotor. So when ferrite magnet is used, so 66 kilonewton meter by meter cube has been achieved. But when you present these topologies by changing the magnets from ferrite to rare earth magnet, so a very high torque density is achieved, about 200 or more than 250 kilonewton meter per meter cubed, with the same structure of both rotor, but the modulator is located in the outer diameter of the machine. Bomela in 2014 presented this machine and this machine used ferrite permanent magnet as well. Another topologies with like a combination between the previous one with the flux focusing machine, but the pole pieces in the outer side of the machine is combined with permanent magnet machine. Ping in 2014 presented this machine with a very high torque density. It's more than 180 kilonewton meter by meter cubed, but this machine is a little bit complicated since many pieces and many rotating two rotating part, and the fixed part is a little bit complicated. Another topologies has been presented by Tsia in 2015. The same, both rotor is flux focusing, but the modulator a different shape, which is L-shape modulator. So 70 kilonewton meter by meter cubed has been achieved by using ferrite magnets. Another one is approximately the same as the previous one, but the modulator is T-shape. So Yen in 2015 presented this kind of machine by rare earth permanent magnet, and more than 280 kilonewton meter by meter cube is achieved for this kind of machine. Now will start with the axial flux magnetically geared machine topology, which have been created so far. So the first one in 2012, Herta has presented this kind of machine. It's a very simple machine with one stator, one modulator, and one surface-mounted permanent magnet rotor. This machine has a very poor torque density of about 15. After that, Wang in 2013 presented this machine, which used as a generator and motor as well, with torque density about 100 kilonewton meter by meter cube. This machine has one stator, two surface mounted permanent magnet, and one modulator. This machine has three air gaps with two rotating parts and two fixed parts. Another topology presented by Zaytoun. This machine presented as a generator with very simple structure, two surface mounted permanent magnet rotors with a modulator in the middle with winding surrounding these pieces. Another topology is presented by New in 2014 with two permanent magnet rotor and one stator with two different kind of winding distribution. So for each winding used to control both rotors. Leah in 2016 presented this kind of machine with two stator with different winding distribution and two rotor. One of them is permanent magnet rotor and the others pole pieces. Another one is presented by Johnson 2017. 7.8 kilonewton meter by meter cubed has been achieved by this machine, since the combination between the magnetic gear and the machine is located, the permanent magnet machine is located in the pore of magnetic gear, so this presents this very low torque density. Another one is 2014 presented by Tong with two stator, two modulator, and one surface mounted permanent magnet rotor. Another one presented by Kushahi 2017, more than 120 kilonewton meter by meter cubed has been achieved. And the last one presented by Zhu in 2017 with two surface mounted permanent magnet rotor and modulator used as a stator in the middle. This one achieved 40 kilonewton meter by meter cubed. The application for this kind of machine include wind and marine energy, automotive application, pump application, manufacturing machinery, and machine operation like drilling and milling. We can conclude some points. This machine is not studied to a great extent if compared with the radial and tubular one. The flux focusing is better than surface mounted permanent magnet machine if you're talking about the torque density, and if you compare with the radial one, high torque density can be achieved by this topologies, and these topologies always used when the axial space is limited. Thank you very much.